server for their updates, right? It happens, right? We have a server for their regular updates. Maybe it's a Linux server or Microsoft server, whatsoever. For their regular updates, it uses internet. In that scenario, this is true. Like it needed internet, as well as it is also been exposed to, as a services. So this is true. That's fine. But let's consider a situation where we need to publish our service over here, let's say in a DMZ zone. Okay, here is the client and here is ISP. Okay, so I'm going to use the same IP 100.22. This is our internet. This is our extranet. Right? This is usernet. This is 192.168.15.47. Let's say the internet user over here sitting, it holds the IP address something like 203.0113. This is the IP segment been used in your lab as well, right? In your lab rectangle, something like that. So it will hit on the public IP interface and get translated on this firewall and reach out to the web server. Right? This is what the scenario is, and this is what called destination NAT. So in this scenario, the source is external. The source is external from your domain. It's not in your enterprise. It is external. The moment it reaches to your enterprise firewall on this interface, the moment it hits, the firewall translates it and take the packet to the destination zone. Now, in order to take the packet in the destination zone, firewall change the header of the IP packet. Firewall change the header of the IP packet. In the header, what it is going to change? The destination address, right? And then only it will come to know with the help of the route lookup that actually on which zone your actual destination lies, right? Before it won't be able to understand. So for that, the moment the packet reaches to the firewall open the packet, change the header with the help of the translation. In the header, it will change the destination address, right? It will change the destination address. And after that, it performs the lookup. It performs the route lookup. The moment it performs the route lookup, let's say our web server is hosted inside the extranet. The traffic will reach to the extranet and the response will be back with the same session or the flow key, right? Client to server and server to client. This is what the scenario is. Okay, I'm going to ask a question to you guys that in which kind of use case this is true? In which kind of use case this is true? Like you guys are working, you have seen this kind of thing. In which case this is true?
In my organization, we hosted some website of the services in the DMZ. So for that purpose, like the few users are there who are able to access the same website through internet. So that's the reason we implemented destination in my company.
Okay. Anyone else?
Could you repeat again one second?
So what will be the proper use case that we are using? So web server publishing is fine. Web server is publishing is fine. But what will be the other scenario? What will be the most common scenario which can be like been used in most of the organizations?
Most of the organization they using another firewall. They did not explore device. They use for another firewall, which will be going through the
maybe
they're using another
external
firewall.
port.
External firewall. They did not use
the common scenario what I have seen in an enterprise level is like this DMZ server is actually, maybe I'm not a web application because most of the organization, they are not publishing any service. The organization which is not publishing any service, those also, having this kind of use case. How? They are, hosting their DNS service externally. They are hosting sometimes their DNS service externally for cloud communication and all, right? If you're owning a domain, and you have GTM kind of architecture in your environment, like you have global traffic manager, which is performing DNS, is authoritative lookup, right? It holds the DNS name and all. So that need to be published over the internet, because if the user is coming from the internet, let's say my organization, www.example.com, right? www, and I own the domain example.com, but the DNS for resolution of this www.example.com is not public. The DNS resides inside my, right? So when I type from here, like when the user net machine client www.example.com, what will happen? I have configured with the public IP address of my DMZ hosted. I have two options. Either I can configure the IP address local of the DMZ, and then it also get resolved. But the thing is, in that scenario, I have to give two DNS servers, right? One which is locally get me resolved, or the other option is I configured one IP address which is available in the public as well. But in that scenario, what will be the issue? The issue is traffic will go out first, right? Because that IP is public. So it is from user net, it get natted and reach out to the internet. Now internet, the IP belongs to my DMZ, DMZ extranet DNS server. It will return back to my firewall, get untranslated again, and this time it will take the traffic to DMZ. This kind of scenario is also called DNS doctoring. I don't know how many people are aware about this term, but this kind of DNS is also, this kind of scenario is also called DNS doctoring. Most of the NATing services are supporting this, like destination NAT services are supporting this. But this phenomena is called DNS doctoring. The client and the response server are behind the same firewall. So traffic which you turn and come back to your server, DNS or web server, whatever, or the one which respond, that is called DNS doctoring. We'll discuss about the DNS rewrite and DNS doctoring more in detail. But this is one use case which is quite common, I have seen. Apart from that, publishing the web server and these things are quite common and quite easy to implement. So let's start doing the configuration and understand that how it is exactly working. Okay. So this is the last one.
एक छोटा सा डाउट है।
Mm-hmm.
लास्ट क्लास में हम लोगों ने पढ़ा था, जब हम लोग बाय डायरेक्शन कर रहे थे, कि
Mm-hmm.
जब ट्रैफिक आउटसाइड से इनसाइड आ रहा होगा तो हम लोगों को प्री जोन एंड पोस्ट, मैं भूल रहा हूँ, प्री जोन पोस्ट आईपी एक टर्म पढ़ा था ना,
पोस्ट जोन और प्री आईपी।
हाँ, तो वो डेस्टिनेशन नेट के केस में भी तो सेम ही होगा ना, अगर बाहर से अगर कोई अंदर में आ रहा तब भी हमें सेम ही फॉलो करना होगा, राइट? या कुछ
बाहर
डिफरेंस आ
से नहीं,
जाता है?
जब बाहर से कोई हिट करेगा, देख
हाँ
लो,
हाँ
दिस इज फॉर द बाई डायरेक्शनल,
हाँ
तो उसका जोन इंटरनेट, राइट? ओरिजिनल
हाँ,
जोन
इंटरनेट,
the destination will already get translated. The destination is already get translated,
okay.
right?
Mm-hmm.
Get translated with the help of lookup.
Okay.
But the packet header was changed later. So that's why we are going to use the same IP address in the destination address. Okay.
ठीक
ठीक है?
ठीक।
The IP, the packet header, the destination header will be changed later. It is just look up for the egress zone, first of all. So that information it takes, that's why the destination zone, it is found that actual destination lies behind usernet, okay? But first time when the policy hits, that time it will check pre-NAT destination IP address, okay?
Okay.
This was the working, like we have tested it and we got multiple hits also, 1628, yeah, we tested it. So your destination translation is also working on the same phenomena. Okay, so let's do it. We just change this one only. So your source zone will be internet, right? Destination zone will be, tell me guys,
usernet.
or you want me to do complete?
आप एक बार टोपोलॉजी एक बार और दिखा देंगे मेरे को, मैं थोड़ा जोन में कंफ्यूज हो गया। इंटरनेट का तो क्लियर हो गया, वो सर्वर अपना यूजर
ओरिजिनल पैकेट बताओ, अभी हम ओरिजिनल पैकेट की बात कर रहे हैं एंड वी आर स्टार्टिंग द ट्रैफिक फ्रॉम आउटसाइड ऑफ आवर डोमेन, सो दैट मींस योर
तो डेस्टिनेशन जोन यूजर नेट रहेगा
in the original packet. Okay,
Should be internet, right?
let's start with the understanding. We'll get there. Fine. Okay, so in the original packet, the source zone will be internet and the destination zone will be usernet, right, Pradeep?
Yes.
Okay, sure. Because we are still outside, and when we are going to hit, I'll tell you the IP address. The IP address source from, let me show the topology. The IP address source from this, 198.168.100.1, and the destination where I'm going to hit is 198. This is not this IP address, wrong. Let me correct it.
The zone will be give the user net, but IP address it will give the firewall internet IP address.
So destination will also be internet, right?
Yeah.
What is that?
Nah, distance it
Exactly.
will,
So let me just.
I am hiding.
Wait, guys. I do understand. 1 minute. So one more time. Source is started from this IP address, which is connected to the firewall, and the destination is also belongs to this IP address only. Now tell me, in the original packet,
Internet.
is your destination zone will be usernet or internet?
Destination will be user net. Internet is a source, destination user net, but IP address will be changed. Destination internet, destination interface is there.
Okay.
The zone will be user net, sir.
Huh?
Zone will be
In
user
original
net.
packet we are talking about. Original packet.
Okay.
Zone changed to usernet after what? Pradeep, after?
After translation.
Sagar, after translation,
After
right?
translation.
We are
Yes.
talking about before translation, original packet. How come usernet? Tell me. Don't learn this, please. It is a bit tricky in this. Don't learn this. Try to understand. Just go to the topology again. Over here, you are trying to hit the firewall currently. So these both interfaces in internet only, right? Internet zone.
Yes, sir. Yes.
How come usernet come? Usernet come only in place when firewall already performed the translation, right? And we are talking about the original packet. Right? Right or wrong?
Okay. Yes, sir.
Tell me, right or wrong?
Yes, right.
Yes.
Right, sir.
What will be the destination address?
198.51.100.1.
198.51.100.
100.1.
36 maybe, right? Or let's take the interface one. 198.51.100.22.
0.
Okay. In translation, we are going to remove this none. And now we are going to change the destination address translation. I'm going to use static IP first. Okay. In the address, what will be the translated address?
98.
Right? Port, I'm not taking port, it's fine. Now check, is that correct? One more time, check. We are not creating policy. We try to understand. We are creating the first the NAT rule, NAT policy. So the packet is sourced from internet zone. Landing, first landing is happening on internet zone only, right? Source, because it is coming from internet, I'll keep it any. But the destination is 198.51.100.22. Okay.
Yeah.
And once it get translated, it will be translated to 192.168.15.47, which is our original destination. Right?
Right.
Commit. Before commit, let's go to our security policy. Now, this is also need to be understood. Guys, please everyone get involved, then only you will get, you enjoy this, otherwise it will be quite boring. So now the security policy will be your original source will be sourced from internet, destination will be this time usernet, destination address 198.51.100.22. Application any, action allow, right? We are not putting any application sort of thing. Is it going to work?
Yes.
How many people are determined? Before I initiate the ping, I want to know theoretically it should be working or not.
Yes, it should work.
Guys, vote yourself. How many people believe it is going to work?
It will work.
Yeah, it's work.
Let's see.
Theoretically, it should work.
Theoretically, it should work. If theoretically it should work, then it should work. And if it not, then I want the reason.
Not working.
Didn't work. What happened?
Show me the
यहाँ से भी route लगेगा Praveen?
Route. First check the log.
We need to check the log, error logs. What's
Yes.
not good. I think so.
Because it is directly connected interface, routing won't come into the picture. Right? See, if we go to network interface, this is the IP on which I'm pinging. So it is directly connected. So routing won't come into picture. After the moment it reach, it get translated, right? So let's check the monitor logs. Nothing.
No logs.
Praveen, we didn't allow the ping.
We didn't allow the ping.
You have to allow the service,
Allow
right?
everything, I guess.
Any protocol already allowed. Any
We
protocol.
allowed everything. No, we didn't.
Go to NAT.
Okay, let me go to NAT.
We are getting
Okay.
So original packet is internal.
What?
And the source is internal. No, I'm checking that. Source is internal. Destination also be internal.
Mm-hmm.
So this is interface. So I put it for the lab. What is the destination interface? I just want to check it.
What? I didn't get you.
Destination interface, sir.
Okay.
I just want to check.
It should be what?
It should be just one, sir. Just minimize it. This one I just want to topology. See the topology.
Wait.
Okay. It is a one by one. One ping to one by one. It will be.
in the translated packet. Did we
Yes, sir.
input
Hmm.
the translated packet?
Okay, now see.
In the translated packet tab, what
In
we
the
have-
translated packet, what was the 192.168.15.47? It get translated into this IP
Not
address.
40. Yes, 47.
Right? Let's see if it is exist or not. What happened to this? Ah. So IP interface, it exists, okay? And 192.168.15.1, it is pinging. Not pinging to its own network?
new
How come? Something wrong. So, sometimes this thing happen like in your simulation. 15.47. Yeah, its own interface it is pinging, but not this.
somehow
see. Firewall
Yes,
rule
IP
is
no
not-
15.1, it will not have
firewall
another
rule
thing.
will
Check
not be
the
played here. I don't think so. Because again, it's a directly connected interface. See, Ethernet 1/2, and the topology, if we go, something else. This is something because of the simulation stuff. See, Ethernet 1/2.
but we did not get any logs for this ping also 15.1.
No policy, is that policy required? You tell me.
We tried ping 15.1 from router, but firewall we did not see any logs.
This is, we are talking about the control plane traffic to its own interface, right?
Okay.
We are not transiting anywhere. Something wrong. Let's see. Because all we need to have a ping management profile connected with it, right? That's it. So if we go inside it, I didn't touch anyway. It was pinging yesterday. In advance, ping profile is there. What is happening? Why happened? Why happened? I changed from auto to up interface. Normally it is checked. The other side is up, then it get up. I don't know what's wrong. This type of stuff happen with simulation. Directly connect interface not pinging. What you can do? If I ping 198, 160, sorry, 192.168, not 15. See? Okay. So it is pinging to the other router, but it is not pinging to the firewall gateway. Ah. Do one thing. Palo Alto. Ping source 192, 168, 15.1 to host 192, 168, 15.47. Wow. What is that? It is pinging now. $11. Okay. Okay. But still over here, if you can see, the ping is not working. Controls not set. Okay. So these exist. Router 1 can ping its firewall interface 15.1 and router 10 also can ping, but from ISP. So that means our NATing policy is not working, right? Our NATing policy is not at all working. And let me just, and the hit count is also not increasing. That means our NATing is not at all in a functional state. See the hit count. Let me reset the hit count. 0. And try one more time. Okay. Fresh. So it's not. See? Before that, just to avoid that fact that point to point is not reachable, something like that. Make ping to that side as well. Ping source 198.51.100.22 to host 198.51.100. Okay. Okay. Let's go to our policy again. It was something connectivity. So our rule is correct, our NAT is correct, and it is reaching. But with this NATing, are we sure that it is actually hitting the firewall and revert back, or it is getting NATed? How can we be sure? Anyone?
Session.
It's working now. See,
Yes, sir.
it's working now. It's get translated. Okay.
That time, why it is not working?
It was like directly connected. Sorry, the directly connected interfaces of the firewall is not working anywhere. See, when I ping from the firewall everywhere, it started working. Some glitch of the simulation. Don't worry about. Maybe the server got restarted yesterday. Okay. When I ping from source to all the connected interface, it started working. Okay.
Sir, in Ethernet port file, we cannot ping the directory to the host to direct to ping the Ethernet interface because they are not with and give it the service route management ping. Sorry, not service route management profile. We did not create. I think so.
What you said?
Management profile, sir. In management profile,
Manager, it was there. It was there on all the interfaces.
every
We checked
interface management is there.
It was there. It was there on all the interfaces.
Why it is not there?
It was there.
There is a management. Advanced. Ping only, yeah.
It was there. It was there. See, ping only. It was there everywhere.
It should be ping.
What?
It should be ping, sir.
Your voice is breaking. I don't get you. Anyways, guys, it was just like a problem with the simulation. Don't worry. Our policy and everything is correct. Okay, because the traffic is not at all reaching to the firewall. So yesterday also this happened, right? But that time the issue was the routing on the end user. But this time the routing is not comes into picture because it is directly connected from the ISP side. And after that, we get this policy. Now the policy says, see what policy says, traffic originates from internet going where to usernet. So with this only we realize this is a NATing because we see the destination address over here belongs to where? Belongs to where? This destination belongs to where?
User
internet. Usernet.
Exactly.
User network.
But what zone says? Zone says
Usernet.
usernet. So this is what we have created in the policy as well. This is what we have created in the policy as well. So post translation, post header change, it will perform the lookup. With the lookup, it understand that usernet, the IP address, the original IP address after translation belongs to usernet with the routing lookup, the connected route information, right? It understand. But the original packet header asks for the destination which belongs to internet, right? So this kind of communication you will see, you will understand yourself with the monitoring log only, that this is getting natted. This is getting natted. The source 198.51.100.1 belongs to internet. How come the destination 198.51.100.22 belongs to usernet? It will not, right? It belongs to the same subnet. See? But still my firewall is saying that the traffic is going to usernet because it is getting natted. It is getting natted, and with the zone lookup, it understands the original, that after translation IP address belongs to my router. We can further, understand this thing after, making a capture on end host, or I can just simply debug. See, from where the traffic is coming, 198.51.100.1, and the source. So this is the ICMP echo reply. Reply is sent by the router itself. So traffic is reaching till here. That means the translation is working fine. So that's what destination translation is. Now then destination translation, if we go, that what are the other type? Got it, guys? So what we did in the very first go, there is no, there is no catch in it. No, I didn't played anything on it. What you just said, I configured. So I hope everyone understand. Or if not, let me know. Okay. So what we did, first of all, let's go back again and check that initially someone says that over here, the destination will be usernet. It would not, right? Because we are talking about the original packet. We are talking about the original packet. In the original packet, the traffic is sourced from internet and landing on internet only, right? Internet only. Now it is the internet traffic. So the source would be anything. But if we want, we can put the source. What will be the source? Tell me.
Yeah.
If I want, what source should I put over here in the original packet?
Original packet in that IP 192.168.
No. Source. We are talking about original packet
Okay,
and
so-
destination NAT. Source will be 198.51.100.1, right?
Yes.
And the destination is the one which belongs to internet, because we are
192.
just as it is, we are putting this. Now in the translation, we'll go and see that what will happen, that once it reach to the firewall as the original packet, it get translated to what IP? The destination get translated to, because we are talking about destination address translation. It get translated to a static IP of 192.168.15.47. It get translated to 192.168.15.47 and
In the
exactly. Okay. Now what are the other types available over here? Sorry. What are the other types available over here is dynamic IP. Dynamic IP. So in the dynamic IP, we can have a range. We can give a range again. So address group. Do we have a range? No. Let's create. For the session round robin, for the session distribution, because this is dynamic IP, it will pick any one of the IP with the help of a round robin as a session load balancing mechanism, or the multiple method. Okay. One is IP modulo. With the help of IP modulo, it will check the IP, which is it perform the hash calculation on it and pick up any one of the IP address. And one is for the least connection. Source IP hash I need to check. So let's give it on round robin only. And so round robin is the most used algorithm in the load balancing because it is going for one
by one.
1:1. Yes. Done. Yes, completed. Why it is not working?
Translation have something problem in the translation.
No, translation we changed, but we didn't change the policy, right? In the translation, the destination address is not changed. Yes. In the original packet, the destination address is not changed. This is the mistake we did. .192.168. The IP pool what we have created, it's wrong, right, guys? We need to create the IP pool of private IP segment, not because we are performing destination NAT, not source NAT. Right or wrong?
Yes, sir.
Yes. But the source router is having
It should, yeah, it should be. So let me just, how can I change? Okay. So 15.47 and one is, let me check only two, 47 and 48. We have two routers there, right? 47 and 48. So 192.168. 47 hyphen 192.168. 15.48. I will change the IP address just, and in the original packet, what we need to do is the destination address will be
47 to 48.
22 only. That is correct. So 198 51 100.22. Okay, so this is the policy which is going to be in use. traffic source from internet going to destination internet, okay, hitting our IP address 198.51.100.22, get translated to any one of the IP address and reached, right? That translation will be happening on the base of round robin. So whichever come first, it will be served first, and consequently other one. In order to test this, we need to change IP address in one of the router which is inside our private segment. So let's go there, and let me change the IP address. One 192.168.15 dot. Okay, so we have two routers. One is 47, one other is 48. Traffic comes from here, landed here, firewall get it translated, and send one packet by packet, stream by stream on one of the routers. I hope it is committed by now. Yes. So let's go. One 198.51.22. Go to Palo Alto. So our destination NAT is in use, and
It's only going to 47.
how you sure about it?
The
It is
log,
always how you sure?
in the log, it is showing only 47.
Where you are
11
seeing?
also there.
No, where you are seeing the, okay,
Here.
these logs, okay. So 11 is also there. See,
But we changed IP to 48.
see, 47, 11 both are there. We can verify this stuff. How? Just run the debug. So we are getting here. Let's debug IP. We are not getting any hit here.
We changed the IP to 48, right? Not 11.
Yeah, not 11. It was the previous log, not
Yeah.
11. Yes. Not coming over here. Okay.
Maybe only once the
End the
ping-
session and then only it will help.
Yeah.
Okay. So when we end the session and reinitiate again, so it is going at both the places, 47 and
Okay.
okay. Because we are running a single stream, it will not. When we change, we will initiate one-on-one because it is picking first time one-on-one, 1:1, right? So it need to be end. So okay. Now there is another type of this destination NAT which we call port address translation. Port address translation is used when your server is running on a service which is of not the port range which is falling under the normal port range, like the one which is falling under 1024, right? The service port range, it is not. You are using some random port to run your service. For example, if someone says that TCP 443, that means the web server is running on HTTPS, right? Simply you can say that. But if someone says that my server is running on port 8000 or 8080, then you will not be able to understand. Okay. So if your server is running on some random port, in that situation, you won't tell your client that while using HTTPS, for example, if your server is running on some random port, let's say www.example, for example, example.com, sir, please type :800, right? Like this. And then only you'll be able to HTTPS my web server. Are you going to say your user? Are you going to trouble them? No. Right? So the user can type by any mean and it should be landed to your web server on that random port on its own. Post translation. So that is called destination NAT port address translation. And this is widely used throughout the industry. This is one use case. The other use case is like, let's say you have only one IP address. Sorry, let's say you have multiple servers, but one public IP address, right? You have multiple server, but one public IP address. In that scenario, let's take example of networking only, right? Networking. So you guys are using their rack.networking.com port 8000, port 888. Like these guys, this is the way they are giving you, right?
Yes, sir.
So that means they are doing some kind of port address translation on their end. When you hit on this port, they translate it and take the traffic to inside some other service port, because they have only one public IP. They have only one public IP, and on that public IP, they are using multiple ports to get the client reachable to their web server.
Yes, sir.
So this is one more thing we need to test. Let's go to policy.
Sir, one more thing is also going on. Sir, whenever we are allowed these rules and the testing time, they are using telnet to access that port actually.
Telnet to?
And get the IP with type the telnet space IP with a port.
And then the port. And then the port. Yes.
Yes. This is the checking for is it allow or not.
Yes.
Here we can do this thing.
Yes. So this is the way we are going to test. We don't have actual web server. How we are going to test? Okay. So we are allowing 23 as a translated port, right? And in the original packet, what we are going to do, we are going to use TCP 2323. Destination port I'm using TCP. So this is the original packet, internet to internet zone, hitting on this TCP 2323 port for this destination address. Translated packet, take the traffic to 192.168.15.47 on which port? This is the port of what? This is the port of?
It is a telnet port.
Telnet
23.
port. So ideally, if someone is hitting from outside, and what else required? Policy. What else required? Policy. So let's go to destination NAT. So in the destination NAT policy, traffic is sourced from internet. Okay. Going to destination user net for any of these IP address. Application, any service URL. What? Over here, the
Telnet.
service URL will be
HTTP. TCP 23.
TCP 2323, right?
Okay.
And
HTTPS.
is it going to work?
No, HTTPS you have to allow.
No. Why HTTPS? We are checking Telnet.
Okay, Telnet is so okay. No, TCP to Telnet
And only
also.
2 or 3 people are involved. Guys, I'm asking that it is going to work with only this much of information in this policy.
TCP base also need to allow, no?
Which one?
TCP base.
TCP base. What is
It
TCP
is
base?
going whole TCP base. It is a TCP base. It is coming to a whole 30. It's a not TCP base. Whenever you use Google app ID, that time is a Google base.
Is it going to work?
The Telnet, you just type it Telnet services.
Wait. Not like this. First, we need to understand. We are not going to make a hit and trial.
Yeah.
Is it going to work?
23, where you create, sir?
What?
23, Telnet TCP 2323, where you create?
You need to configure on router.
In the
Telnet.
NATing, I did in the NATing. In the NATing,
Okay.
in the original packet, I'm saying that someone is coming from internet, going to destination zone internet, okay, and using the service 2323, okay. Destination address is the public IP address of the same zone.
Sir, by default,
Get
TCP
translated.
23.
Wait, let me complete. Get translated on this real IP address. This real IP address belongs to the router, reach to the actual service port, which is Telnet. This is the entire flow.
Telnet.
So now I am saying the policy also need to be allowed. Now what policy says right now? Policy says that the traffic is sourced from internet, going to destination user net, because it get translated first for destination 198.51.100.22, which is okay. But in the service, I allow TCP 2323. Is it going to work?
It's already translated, so you have to allow 23.
23.
Okay, so after translation, it is reaching out to usernet zone. So you are saying that if I remove this TCP 2323 and only allow
TCP
23, it will work.
Yes.
How many people agree with this? Please say yes, no, everyone. I want to everyone involvement. We're not here to learn all these things. We need to understand. Please.
I agree and okay and commented to look at.
So what need to be allowed? Tell me. Is it going to work with TCP 23 only?
Telnet only.
Only Telnet? No need of TCP 2323?
Only Telnet, sir.
Okay.
No need.
Everyone agree with that, right?
Yes, sir. Someone's sleeping, sir.
Everyone is sleeping.
I think so. They are not giving reply when he's sleeping.
Anyone is not giving reply. Anyways, fine. Committed? Yes. Time to test. How we are going to test it? Telnet?
Going to in
198.51.100.22. 2323?
Yes.
It's not working.
Why?
Not 2323. You
Yeah,
2.3 only,
we
right?
have
This
to,
is the original packet. This is the original packet.
okay.
2.3.
We have to allow the 2.3.2.3 also, I think. Yeah.
This is what I was asking. We are not doing hit and trial.
Mhm.
Why 2.3.2.3? You're not learning.
Because of in that case we have given the translation is a original packet 2.3.2.3, and so in policy also security policy.
See, first of all, see, traffic is originate from internet. After translation, it goes to usernet. It understands. But apart from
Okay.
that, it is not translating anything. It needed everything original. See,
Okay.
that's why 2.3.2.3.
Mm.
But is it 2.3.2.3 only sufficient?
No, IP address should be translation also.
23 also should be there.
Who is this?
Rakesh.
Rakesh. Thank you, Rakesh. So both need to be allowed, guys.
Yeah.
That is what I was asking. When I allow TCP23, someone says that TCP23 also need to be allowed, like telnet also need to be allowed. Fine. So we have seen in the monitor log what is exactly dropping. Okay.
Action denied. Yes.
Hmm.
Yes, exactly.
Okay. We have R1. Time of truth. Let's go to check the logs.
Every policy we have to allow the telnet only, but check the policy.
Okay, why log is not coming? Fast. This answer I want fast.
We have to close the session.
Why?
We have enabled log after the session.
At the
end.
session end. Who is this?
Rakesh.
Thank you, Rakesh. Still log is not coming. Something else.
Go to security policy, we have to check give it that
It
session.
takes some time. It's fine. It takes some time.
It already coming, sir. Telnet is allowed.
Yeah. Okay. So this is your port translation. And here we are end with destination NAT.
Okay.
Naveen Babu. Okay, Babu, have you seen that book?
Yeah, just started actually. Yeah.
Okay.
Especially I'm looking for the NAT topic.
So that is little advanced. Okay. Like you asked for from beginner to advanced, that books was given by earlier from networking only. It been mentioned about mind meld and all those stuff. Okay, mind meld is no more like when at the time the book was written, that time mind meld was there with Palo Alto, but it is no more. It is changed to Cortex. Mind meld was actually held by Demisto earlier. Okay, but now it has been changed. Okay, so those
Do
things.
you have any, I don't know, from the starting guide? That is why I asked for from basic to advanced. So
Starting to end, there is an official PCNSE Palo Alto guide. I can give it to you. Download from the official site.
yeah.
So that you can follow. but it is quite, quite advanced. From beginner to end, line by line, if you read, you get to understand few things over there. But
I want to read line by line because security is.
Okay, I'll get it downloaded and give it to you. Okay.
Okay.
Now, before going further, I have some few questions related to knowledge check. Okay. Because the next topic will be this app ID. How to make it big?
We can check the error logs, in the CLI as well, right? So for the NAT which we didn't work. So
Yes, you can check. Show session ID or show session all. It will show all the sessions for natting. Tell me, which two items are required? Match criteria and Palo Alto network security policy.
John and
Guys,
destination.
not like this, not like this. Put your answer in the chat. Fast, 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 fast. 1 and 4. Source and okay, 1 and 4. Okay, so 1 and 4 is the correct answer. Thank you.
Configuring.
When configuring a new security policy rule, which is the default rule type?
Intrazone and intrazone.
When configuring a new security policy rule, which is the default rule type? When configuring.
Okay.
When we are configuring.
Default.
Let me show you. See?
Universal type. Okay.
will be universal.
Exactly. So 3 types were there, right? Interzone, intrazone, and universal. When we create universal, that means it will be applicable for whatever we have given over here, right?
Okay.
Whether it be interzone or intrazone, it will going to match our zones, right? So answer is
Universal.
This security policy was quite old now. We are studying natting, that's why. In the note, in the text note, what I have given, it was there. 3 types of policies: interzone, intrazone, and if it is not there, so maybe I have not given you the updated one. This one? NAT oversubscription is used in conjunction with which NAT type?
Destination. Sorry,
Hmm?
dynamic.
NAT over subscription is used in conjunction with which NAT type? First.
Dynamic IP.
Answer not like this. Answer in chat.
Okay.
Hmm. Rakesh, you have given. Okay, sorry. Rakesh, you have given two answers. Which one which one should I mark
The
correct?
earlier one was for the previous question.
What? Okay, sorry. Sorry. 3 dynamic IP server. Okay. What about others? Nobody's interested in this? Ajit, Nilak. Okay.
I have been confusing 3 and 4, sir.
Why
I
you are
didn't say.
confused? Tell me. What it is saying with NAT over subscription.
NAT
When we are
over
using,
subscription using which is NAT
when we
type.
are, let me listen to me. When
Oh,
we are
yes.
saying NAT over subscription, which NAT it is? First, try to understand which NAT it is. NAT over subscription is which NAT?
Dynamic NAT.
Dynamic NAT. Okay.
When
And
dynamic
in
destination
conjunction with which? No. NAT over subscription is used in conjunction with which NAT type?
it is a destination NAT type. You need to-
Okay. It's I understand you guys understand this question. I know that's why I'm getting correct answers, many of them, but it's kind of like English thing. It's not actual question. Read it carefully. NAT over subscription is used in conjunction with which NAT type? Okay, Babu, Sagar, and yes, Babu and Sagar is correct. Okay, so the answer, I'll tell you, the answer is dynamic IP and port. Answer is dynamic
That's
IP and
what
port.
I'm saying.
Okay.
And 4.
Not 4, 3.
3, I say that's why I'm saying that. I'm confused.
I have shown you in the advanced, we have configured that part when we are using dynamic IP, right?
Yes.
We configure NAT over subscription in conjunction. Sorry, the question I missed. Which action in security policy results in traffic being silently rejected?
Deny. Sorry.
Answer in chat.
Chat.
Yeah. Silently rejected. Rakesh, Ajit. Babu. Sagar. So the answer is drop. Okay. So many people are right. Few people are wrong. When firewall drop, then only it is silently rejected. Deny, client comes to know. maybe with some web page or something like that, your access has been denied, this kind of message is thrown. Okay, true or false? Logging on interzone default and interzone default security pool rules is enabled by default. True or false? Logging on intrazone default and interzone default security policy rules. Thank you. So for the answer of this question, almost everyone is correct. So its answer is false. By default, logging is not enabled on these rules. Okay. And that is also always it is suggested that while working on a production level environment, create your own deny policy, which should be universal, and put a logging on it, because the one which is always available as default, it is not going to work. Like logging, you can't see. If it is dropping, the log will not be available. Monitor logs will not be available. In our case, it is because you remember I overrided it. See, it is currently override. I overrided and changed the policy. So don't get confused. The reason for asking this question, because you guys are keep on seeing these logs because of interzone, because I enabled it purposefully. Okay, because I don't have any deny statement. When you're working in production, it is always suggested that at the bottom of your own configured policy, create a policy where there is no match available at the bottom, it should be denied. And at the top of it, create your own specific policies. Okay, so that if it is dropped by the firewall, you can see in the monitor log, because the default policy which is already available in the firewall, it is not going to show you anything. Okay, so this is like destination NAT firewall policies. In the firewall policies, so far we have seen address object group, DAG. In the dynamic, in the NATing, we have seen destination NAT. We have seen source NAT. In the destination NAT, we have seen 3 types. One is static, one is dynamic. Dynamic, we have seen round robin. You can change the other modulos as well and check that how it is load balancing. And we have seen port redirection as well. So the one we have discussed, it is called port redirection. In the next class, I think you have the lab for this NATing thing as well. What we have discussed, this port address translation was there. In the next class, we are going to discuss about app IDs. Okay, in the next class, we are going to discuss about app
IDs.
Let me see what's there in the next as a content edu. Wow. You see, Chat GPT is available now in Bing. Yes, so we have covered so far topic till topic 7. In the next class, we are going to see the functionality of app ID. Okay, guys, see you in the next class. I don't have, like, in 10 minutes, we are not even, complete anything about it. So let's start afresh in the next class. Okay, about app ID.
Okay, sir, I have one doubt, sir. Could you clear that?
Ask me. You have time.
Sir, in my production, one have a Cisco Miracle switch. And the other side have a Cisco character switch in the data center.
Cisco Catalyst.
Catalyst switch. They have a point-to-point connection. Airtel and Tata. And one sided 253 and my local sided 254. I'm trying to data center. I'm trying to ping in my location to data center pinging. But whenever trying to ping my local IP 254, it is not pinging. After some time, it will giving the notification. The link is working, internet accessing, everything is properly working, but ping is not working. After 1 o'clock, after 1 o'clock, it will ping is automatically ping. It will work. Why, sir?
After 1
Hello?
o'clock. So which firewall in between? Is there any firewall or just
Don't have any firewall. The point-to-point location don't have any firewall. Our data center have firewall.
Your traffic is crossing through data center firewall?
Yeah, crossing the data center firewall. So it is a point to direct to connected the switch to switch. Point
Okay,
to point.
so you are pinging
P2P
from
connection.
your in-house switch to the Meraki gateway, right? Directly.
Yes, sir. Yes, sir.
And Meraki gateway and your own switch is having the point-to-point connection.
Connection. Yes, sir.
Do you,
And whenever other Meraki switch is there.
have you checked any kind of scheduled policy on Meraki itself?
Yeah, yes, sir. Yes, sir. I have all the thing I've checked. Nothing is there. Any policy by default policy I have only.
That's
I've
quite
checked the
strange.
protocol.
Like, so what you are saying, it makes only sense to me if there is any scheduled policy, like after 1 o'clock it is working. You specifically
Yeah, I
mentioned
know, sir.
that.
This is maybe scheduled policy, but I've checked the Meraki switch. Don't have any scheduled policy. And I go to policy section. I check the by default allow in any by default any is available. That is the big sir. Like in 3 days, I am doing this thing. I have checked the ARP table. If the ARP table is learning, they are learning the MAC address also, both sides. Even whenever another Meraki switch, which is my gateway, though I will create in Meraki switch, it's a 4 VLAN I created, and another gateway which I have connected to the Wi-Fi. That gateway will be not pinging. I can't access the internet. But gateway is not pinging. After 1 o'clock, whenever the 254 pinging, a gateway will be pinging. Hello.
Can you show me this?
Right now, no, sir. Right in my office have actually.
And okay,
I can.
Friday.
I can.
Friday.
Try to.
Wait. Friday it is off for me. Okay.
Okay.
So
I will
Friday
try.
possible for
definitely.
you in the daytime, not night at the class, not at the class time.
No, daytime. My job is 10 to 6.
Okay, show me. Maybe I can have some idea.
Yeah.
Because in this way it is quite
Okay,
observed behavior. I can't say anything. Okay.
Yeah, I know. I can because I have a only read only. I try to capture the packet. I can't because I have a only login read only permission.
Okay.
Yeah.
Okay, guys. See you. If anyone having any question, they can ask. We have like still 5-6 minutes left. Or I'll just end the session.
Thank you, sir.
Okay, I'll take it as no. See you in the next class.
Your guide, so the basic Palo Alto.
Yes, Babu.
Thank you.
Babu, you are saying something?
No, I said okay.
Okay, I'll post the book, PCNSC guide, in the group. Okay.
Okay.
Okay, thank you.
Yeah, thank you.
Bye-bye.